In the class on ordinary least squares, we talked about the t-test and the f-test. The t-test to see whether any particular beta coefficient is significantly different from 0, and an f-test to see whether all beta coefficients together are significantly different from 0. And we also discussed some f-tests that test for particular restrictions, whether you can see whether a whole group of beta values are different from 0 or not. For example, if you want to test all the beta coefficients on a set of dummy variables that capture the same categorical variable. So these latter tests, they are tests for restrictions. You have a restricted model where a set of coefficients are removed, the set of variables are removed, and you have an unrestricted model where you have the full set, and you compare the two against each other. If they significantly differ, then you need the additional variables, and if not, you don't. In the maximum likelihood framework, we have similar tests. Because we have asymptotic normality of the coefficients we estimate, we can perform z-tests for any of the individual coefficients. To assess restrictions, we have a set of different tests. And in this video, I want to discuss the set of tests that we typically use in the cases of these restrictions. So we will discuss the likelihood ratio test, the Wald test, and the Lagrange multiplier test. All three test for a set of restrictions, so they test the restricted against an unrestricted model. And asymptotically, they're pretty much equivalent. So as your sample size grows larger, they will give you the same results. But when the sample size is not as large, this might vary. So the likelihood ratio test very simply looks at the ratio of the two likelihoods. You estimate two models, and given then certain parameter estimates, you can calculate the log likelihood function. So we've discussed how when we estimate the parameters, we try to find the maximum log likelihood. So we find that set of parameters that makes the data most likely, assuming our model. Now, if you have a restricted model, you will get a somewhat lower likelihood than if you have an unrestricted model. And whether that difference is significant or not, we can evaluate by looking at the ratio of the two. So we can look at the log of the ratio of the likelihood of two models given their estimated parameters. And this will then follow a chi-square distribution. So we can see whether it's large or not and whether it's statistically significant or not using the chi-square distribution. So this graph gives you a little bit the intuition behind this argument. So the curve that you see is the likelihood function for the unrestricted model. And the point where it says unrestricted is the estimate for the beta coefficients for theta. Theta is a sort of groups all the parameters together. So we have a particular estimate for theta that maximizes this likelihood function. If we had a restricted model, we would find somewhat different maximum likelihood and a different value for theta. And the differences in these likelihoods, so the vertical difference between these two estimates, that captures the likelihood ratio. The Wald test only requires one estimation. So to calculate the likelihood ratio, you need to estimate two models, an unrestricted and a restricted model. For the Wald test, we only need to estimate the unrestricted model, and we look at the likelihood function of the unrestricted model. And we look at the second derivative of the likelihood at the point that maximizes the likelihood function. And the second derivative tells you something about how quickly the slope changes at that point. And the intuition is that if the slope changes quickly, the difference between an unrestricted model and a restricted model is going to be very large, because a small move away from the optimal point for the unrestricted model leads immediately to a much lower likelihood. On the other hand, if the slope changes slowly, then you can move a bit away from that maximum point and still get a good likelihood. So a restricted model might very well still have a good fit with the data. So here you see two possible likelihood functions for the unrestricted model, one that changes quickly and one that changes more slowly. And the one where you change more slowly, if you would move from the point of the restricted estimates to the unrestricted estimates, from the unrestricted estimates to the restricted estimates, you see that when the curve changes fast, you would get a much lower likelihood, but when this curve changes slowly, you would get only a moderately lower likelihood. So we can test for whether restrictions might be possible using just the unrestricted model and the Wald test. However, because we do not estimate the restricted model, of course this test performs less well if the restriction is very severe. It tells us only something about how severe restrictions are going to be if they are not too severe. So it is a sensitive test, sensitive to the actual restrictions we want to implement. And therefore, if it is possible, we would probably prefer the other two tests. So where the Wald estimator only required estimation of the unrestricted model, for the Lagrange multiplier test, we can estimate the model with the restrictions and then look at the slope of the likelihood function of the unrestricted model at the point of the estimate for the restricted model. So if this slope is steep, then an unrestricted model would probably have a much higher likelihood. And if the slope is not steep, an unrestricted model will have a moderately higher likelihood. So we can use this to test whether the restrictions are severe or not. So here we see the intuition. We look at the point on the likelihood function of the unrestricted model for the estimates of the restricted model, and we look at the slope. And you can see that if this is very steep, then the unrestricted model will have a much higher point on the likelihood function than the restricted model, and we would reject the restrictions. But if the slope is not steep, then the unrestricted model would have a very similar value on the likelihood function.